All right, so simplifying radicals. What is a radical?
I don't know.
The square root. This thing. So we're going to take the number on the inside and simplify it. So that's simplifying radicals. So the simplest form of a square root expression, the radical has no perfect square factors other than 1. The radical has no fractions, and there are no square roots in any denominator. To simplify a radical expression, remember that the square root of a product is equal to the square of the roots. Also, the square root of a quotient is equal to the quotient of the square roots. So if we have two numbers that are being multiplied, a and b, that are under a square root, we can split that up into two different square roots and multiply them. So we could do square root a times square root b. So these are the same thing. And the same works for fractions. So if we have one fraction under a square root, we can split it up as the number on top is under one square root and the number on the bottom is under the other square root. And now we're just going to do examples. So what is the square root of 4? 2. 4 is what we call a perfect square root, because it comes out to be a whole even number, a whole number. What's another perfect square? 64. So if we take the square root of 64, what would we get? 8. What's another perfect square? 81. What's the square root of 81? What's another perfect square? 25. What's the square root of 25?
5.
What's another perfect square? 16. What's the square root of 16? What's another perfect square? 9. 3. What's an...
36 for the next one.
All right, 36. What's the square root of 36? What's another perfect square?
49.
49.
1 million.
What's the square root of 49?
7.
What's another perfect square?
1.
1. So what's the square root of 1? What's the square root of 100? What's another one?
112. Wait, what's it? Yeah.
169. What's the square root of 169? 13. What's another perfect square? 121. What's the square root of 121? 11. And one more. 144. What's the square root of 144? 12. These are common ones that you'll see. Okay. Let's do number 2. So the square root of 18. The first thing we can do is break up 18 into 9 times 2. So now we have the square root of 9 and the square root of 2. What's the square root of 9? 3. So 3 root 2. So another way we can look at this is the square root 9. What does 9 break into? 3 and 3. So we have 3 times 3 times 2 will give us the 18. We can take a pair of numbers under the square root and move it outside of the square root to a whole number outside. So we have 3. So we're taking the pair of 3's and just making it 1 3 outside. And then we're still left with a root 2 on the inside of the square root. That's it. Okay, let's do another example. Square root 20. What can we break 20 into? 5 and 4. Can we break 5 into anything?
Wait, why can't it be 10 and 2?
We could do 10 and 2.
Oh, no.
We could do 10 and 2. We'll do 10 and 2 next. Can we break 5 into anything?
No.
Can we break 4 into anything? 2 and 2. Can we do anything else? No. So we have a pair of 2's that we can move to the outside of the square root. So we have 2. And what are we left with on the inside? 5.
Can you explain it to Matthew that you can also can you do 10 and 2?
That's what we're going to do that here. Alright guys, so we can split this up into 10 and 2. Can we split 10 into anything?
Yeah.
2 and 5. So we have a pair of 2's here that we can move outside of the radical. So we have 2 root 5. We get the same answer. Okay, let's look at number 4. We can split this up into 9 and 3. Can we split 9 into anything?
Yes.
3 times 3. Can we split 3 into anything? No. So we have 3 times 3 times 3.
So it's 3 square root.
So we get 3 square root 3. So we just take out a pair and put it on the outside. Any questions so far? Okay, let's do number 5. Can we split square root of 32 into anything?
Yes.
4 and 8. Can we split 4 into anything? 2 and 2. And what about 8? 4 and 2. And we can split 4 into 2 2's also. So we have 2 times 2 times 2 times 2 times 2. So we have how many pairs of 2's? 2.
It would be 4 square root of 2.
Right. So we have one pair of 2 that we can take out, make it 2, and then we can take this one out too. So we have 2 times 2 in front of the square root. And what are we left with inside the square root? 2.
Can you make it 4?
Yep. What's 2 times 2? 4. So we have 4 square root 2. Number 6. What can we break square root 48 into? 4 and 12. What can we break 12 into? 3 and 4. So we have a pair of 4's, right? Right, so we can just take out the pair of 4's. We don't have to break the 4's down into 2 if we have a pair of 4's. Well, we can take out the 4 to bring it in front. And what are we left with under the square root? 3. Any questions? Let's look at number 7. Square root 50. 10 and 5. So what can we break 10 into? 5 and 2. What can we break 5 into?
Can't you just bring it down?
We can just bring it down. We can't break 5 into anything else. So what do we have a pair of? 5. So what do we do with the 5's? 5 square root 2. Perfect. Massimo, what can we do with square root of 72? 36 and 2. And what can we break 36 into? 6 and 6. Do we need to break it down more? No, because we have a pair of 6's that we can take out. So what do we get for our answer, Massimo? 6 square root 2. Perfect.
What if you did it 92?
It's the same thing. 'Cause
So you'll get the same thing. So if we have square root 72, and we break it down into 9 times 8. What does 9 break down into? 3 times 3. What does 8 break down into? 4 times 2.
So would you have to break down the 4?
We don't have to because we know that square root 4 is equal to 2. So we could take out the 4 and make it a 2. Does that make sense? Because 4 breaks down into 2 and 2.
Yeah.
So we're taking out this pair of 2's that's in the 4 and making it a 2 on the outside. And we also have to take out the pair of 3's, make it a 3 on the outside. We're left with square root 2. So it's 2 times 3? 6 square root 2. So we get the same answer.
So I have to multiply this 2 pairs.
Right. So you have to multiply whatever you pull out in front, you'll have to multiply that. If we had 2 numbers that were still on the inside, like say we had a 2 that didn't have a pair and a 3 that didn't have a pair, we'd have to multiply the numbers on the inside too. Which there'll be an example like that. Any questions? All right, number 9. What can we break the square root of 98 into? What's any number that goes into 98? 49. 49 times what? 2. What can we break 49 into? 7 and 7. And we still have a 2 on the inside. So we can take out this pair of 7's, put it on the outside. What happens to this 2 that's already on the outside? We multiply it. So what's 7 times 2? And what are we left with on the inside? Square root 2. So 14 square root 2. Okay, number 10. We have a negative 3 on the outside. And how do we split up 150? 30 and 5. We can do that. So what can we split 30 into? 5 and 6. And can we break anything else down in here? So 6, we have a 3 and a 2. So do we have any pairs in here? We have a pair of 5's that we can take out and put it in the front. So we have negative 3 times 5 in the front. And under the square root, what do we have? 3 times 2.
Do you have to break down 6?
If you know that it's not going to break down into anything, like if we had a 2 in here, we would need to break it down to know that the 2 and the 6 pairs up with the other 2. So what's negative 3 times 5? Negative 15.
Yeah.
So what's 3 times 2? So inside the square root, we're going to get square root 6. So we have to multiply the numbers on the outside and keep them on the outside. And then we have to multiply the numbers on the inside and keep them on the inside. So this right here is the simplest form. We can't break down square root 6 into anything else. So if we had square root of 150, we would do 15 and 10. What can 15 break down into? 3 times 5. And what can 10 break down into? 5 and 2. So we have a pair of 5's that we take out. And we're left with a 3 and a 2. So we multiply the stuff on the inside and we get 6. Okay, number 11.
What was 10?
76 times 2.
Negative 15 root 6. So you have a negative 2 on the outside, and what can we break down 162 into?
81 times 2.
What is it?
81 times 2.
81 times 2. If the number is an even number, right off the bat, you know that 2 is going to go into it. So divide 2 into it and see the smaller number that it gives you. And then maybe you know what else goes into that. What can we break 81 into? 9 and 9.
So that's instantly already a pair.
Instantly already a pair, so we can just take out the pair of 9s. So it would be
9 times negative 2 should be negative 18 square root of 2.
perfect. Negative 18 square root 2. Let's do number 12. What goes into 288? 144 times 2. What does 144 break down into?
12 and 12.
12 and 12.
So it's also
So we have a pair of 12s that we can just take out. So we don't have to simplify the 12s into 2 and 6. So we can just take out the pair of 12s. 60 square root 2. Perfect. Alright, let's look at 13. So since we have a fraction inside the square root, we can say that we have square root 72 over square root 2. So we're just making this two separate problems. How can we break down square root 72? What goes into 72? 12 and 6. What goes into 12 and 6? Or what goes into 12? 3 and 4. What goes into 6? 3 and 2. Can we break down anything in here? Can the 4 break down? Yeah. So we have a 3. What does 4 break down into? 2 times 2 times 3 times 2. So we have a pair of 3s that we can take out and a pair of 2s. So we have 6 square root 2.
But what happened to the square root of 2? I just bought it.
Right now we're just dealing with the top. So this all has to do with the top. Now, can we break down the square root of 2 that's on the bottom anymore? No. So we have 6 square root 2 over 2 over square root 2. If we have a square root 2 over a square root 2, what does that become? They cancel each other out. So what's our answer? So our answer is 6. All right, 14. What can we break 80 into? 8 and 10. We could do, there's more than one way to do it, right? So we could break it down to 2 and 40, or 8 and 10. What can we break 8 into? 4 and 4. 4 and, what's 4 times 4?
4 and 2.
4 and 2. And what can we break 10 into? 5 and 2. Can we break down the 4? Into 2 times 2. Then we just drop down the rest. 2 times 2 times 5. So we have a pair of 2's here that we can bring out, and a pair of 2's here that we can bring out. So we have 2 times 2, and what do we have left under the square root? 5. So what's our answer here? 4 square root 5. Perfect. All right, 15.
1 over 5.
So we can say we have the square root 1 over square root 25. What's the square root of 1? And what's the square root of 25? So we have 1 over 5 is our answer.
16 5 over.
So we get 16. Francisco, what can we break 33 into? 11 and 3. Can we break it down any more? Do we have any pairs here?
No. Wouldn't it just...
So 33 is the simplest form that it could be. Square root 33 is the simplest form it can be. So we can't break it down into anything else.
Like on the quiz, how would we say that?
You just leave it as square root 33, or you could say it's in its simplest form. Okay, 17. Can we break down x squared into anything?
Yes.
X times
X.
x. So we have a pair of x's that we can move to the front. And what do we have?
X.
Just x. $18. Square root of 256. 2 and 128. So we leave the 2 there. What can 128 break up into? We know 2 goes into it because it's an even number. So we could say 2 and 64. What type of number is 64? A perfect square, right? What can 64 break into? 8 and 8. So we have a pair of 2's and a pair of 8's. So we move the 2's on the outside and we move the 8's on the outside. So we get 2 times 8, which is 16. So our answer here is 16. Okay, 19. What can we break 25 into? 5 and 5. So we can take the pair of 5's, put them on the outside. So we get 4 times 5, which is 20. Last one, number 20. We have the square root of 26 over the square root of 4. What can 26 break down into? 2 times 13. Can 13 break down into anything else? No. So we have no pairs. So 26 is the simplest form it can be. So we leave this as square root 26. What about the bottom? What's square root 4? 2. So this is our simplest form. You can't solve it because it's not an equation, but we're just simplifying it. So it's giving us a number and we have to simplify it.